In this small video, I would like to discuss regarding the acceptance criteria of strength for concrete as specified in IS 456. One major aspect as far as strength is concerned, we should remember that the strength what is mentioned generally is a characteristic compressive strength. Why it is mentioned as the characteristic compressive strength? Because it is not the actual strength, but it is representative strength of the conduit which you are producing. It states that it is a strength below which not more than 5% of test results are expected to fall, because the strength of conduit depends upon so many factors that we cannot say that the strength of conduit should be a particular value, nothing more, nothing less. It will never happen. It is not possible to manufacture such a conduit. So always there is a probability that some values will be below the specified value, some will be above the specified value. So it is a statistical calculation of strength of a conduit based on the test results. A large number of variables are deciding the strength. So the mix is required to be designed first of all. Once the mix is designed, whether we are achieved the same mix on the ground, that depends upon what is the test reports of the cubes we are testing. How to decide the strength? It is a compressive strength of 150 mm size concrete cubes at after 28 days of specified curing. The characteristic compressive strength is tested only by testing the cubes in a specified way after specified curing. That is why it is called a characteristic compressive strength, not simply the strength. Remember that when you are discussing hereafter, specimen means one cube and sample means always set of 3 cubes. Wherever in the IS code when you are seeing, when you are reading that as a strength of a sample, remember that it is strength of a sample average of 3 cubes, not the strength of 1 cube at any point of time. That also with the restriction that these 3 cubes, when it is tested, the variation shall not be more than 15% from the average. If any of these 3 cubes are having a variation more than 15%, that particular cube is to be rejected out of that particular lot for calculating the average, and you can test 4th cube and take the average again. How many samples are to be tested? It is given in class 15.2.2. It depends upon the volume of conduit for which you are doing the sampling. Now when you are designing the mix, you are designing for a target mean strength which is equal to FCK plus 1.65 S, where FCK is a characteristic compressive strength and S is a standard deviation value. From the definition of FCK, that 1.65 has come, is a constant which has come from the definition of FCK as that 5%. Standard deviations are given in table 8 of the IS code. For example, for M25 conduit, the target mean strength will be 25 plus 1.65 into 4 is equal to 31.6 Newton per millimeter square. But remember, this is a target mean strength for designing the conduit, not for accepting the conduit. Many people have a confusion between the target mean strength and the acceptance criteria. This 31.6 Newton per millimeter square is a target mean strength for which we should carry out the mix design. 31.6 is not the acceptable value of the cube strength for a M25 conduit to accepted site. That is something different. That is what we are going to see today. It is given in clause 16 of IS 456 that the mean strength of a group of 4 non-overlapping consecutive test results shall comply with some certain values given in table 11. First of all, we should understand this word mean strength of a group of 4 non-overlapping consecutive test reports. Let us see what it is. I have given a table, for example. There is specimen number 1, 2, 3 up to 18 specimens are there, and strength is given. For example, first specimen, first cube is 28, second is 27 Newton per millimeter square, third is 30 Newton per millimeter square, fourth is 27, like that. Now serial number 1, 2 and 3, 3 specimens together make one sample, sample number 1. The average of 28, 27 and 30 works out to 28.33. Then 4, 5 and 6, average is working out to be 28, that becomes sample number 2. So there are 1, 2, 3, 4, 5, 6 samples in this particular table. IS code says mean value of 4 samples, mean value of 4 test reports means not the mean value of 4 specimen, remember, it is a mean value of 4 samples, sample number 1, 2, 3 and 4, that is the mean value of 28.33 plus 28 plus 27.67 plus 29.67, which works out to be 28.42. This value should not be less than a specified value in table 11, that we will see separately. Now, there is a word called non-overlapping. What is non-overlapping? You cannot take 1 cube from sample number 1 and 1 cube from sample number 2. Just because one value is very less, in the sample 1, 2, 3, 4, the sample number 4 is having a very less value. So, we will just discard it, we take 1, 2, 3 and 5, that is not acceptable. So, it is non-overlapping, consecutive test report should be taken. No value of sample from one set can be repeated in taking the average of another one. For example, 1, 2, 3 and 4 is already taken. Now, you cannot take 4, 5, 6 and 7. It has to start from 5, 6, 7 and 8. That is non-overlapping. Now, what is this values given here? Let us see. This is a table 11 of the IS code which I have reproduced here. For all specified grades M15 and above, mean of the group of 4 non-overlapping consecutive test reports shall be more than FCK plus 0.825 of the established standard deviation or FCK plus 3, whichever is greater. Remember, you see the word established standard deviation. In the established standard deviation means when you are testing the cubes, when you are testing at least 30 samples, you calculate a standard deviation from the statistical values of those statistical methods from the actual values achieved at site. That is the established standard deviation. The note says, in the absence of established standard deviation, the values given in table 8 may be assumed and attempt should be made to obtain the results of 30 samples as early as possible to establish the values of standard deviation. In the beginning, you can use the approximate arbitrary values given in table 8, and subsequently when at least 30 samples, 30 good samples are available, from that, from using statistical formulas, you work out this standard deviation multiplied with 0.825 plus FCK, that should be the value. That means, in the table 28.42 should be more than FCK plus 0.825s or FCK plus 3, whichever is greater. Now, as you can see there, for checking this, we require at least 12 specimens or 4 samples. Assume that your volume is less, you are having only 1 sample and 3 cubes and 1 sample, then also IS code says, for concrete quantity up to 30 cubic meter where number of samples to be taken is less than 4 as per the frequency of sampling given in 15.2.2, the mean test result of all such sample shall be FCK plus 4, not FCK plus 3, and the minimum and the requirement of minimum individual test report shall be FCK minus 2. On the right side on column 3, the individual test result value should be FCK minus 3 at least. Remember, individual test result means individual test result of a sample, not a specimen. Specimen, I have already told you, any cube having a value which is varying more than 15%, that particular cube should be discarded, quantity need not be discarded. That particular cube value should not be taken in doing the averaging. Does not mean that the quantity has failed, that particular cube is not made properly. So, that value of the cube should not be taken in calculating the average of sample. The individual test results in Newton per millimeter square given here is the value of one sample of 3 cubes. So, each of these sample which I have shown 1, 2, 3, 4 samples, each of that should be at least more than FCK minus 3 and average should be FCK plus 3 or FCK plus 0.825. Yes, that is what is required. Where number of samples are less than 4, then instead of FCK plus 3, it should be FCK plus 4. That is the minimum required. Assume that there is only one sample of 3 cubes, say 5 cubic meter of concrete, then both the values should be FCK plus 4. FCK plus 4. That is the acceptance criteria required for concrete. Now what will happen if this is not acceptable, if this has failed in the sense this value is not achieved? IS code clearly says what action is to be taken then, technical action. The IS code says we should go for a core test. In case these values are not in acceptable limits, the cube strength is not as per this. It may be due to because the cubes are not made properly or it is not cured properly. IS code says you have to go for core test. How it is to be done, it is given, or non-distorted testing is to be done, or on flexible members when load test is to be done before rejecting the work. If all these things fails, then only the structure should be declared unsafe. This is the acceptance criteria given in IS 456. This should be clearly understood. This is how the cubes are to be tested, and this is how how to decide whether we can accept it or we can reject it. A similar clause is also given for fluxural concrete, almost similar philosophy. You can read it. It is very simple to understand. I think this video is useful to you. Thank you very much.